Okay, thank you for joining us today. This is the second webinar of our bi-monthly. Um, this one is titled Chalk River Laboratories Decommissioning Spotlight, B250 Project Update, and Dedicated Isotope Facility Webinar. First off, CNL respectfully acknowledges that the Chalk River Laboratory site is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe Nation. We recognize and appreciate their historical connection to this land, and as the customary keepers and defenders of the Ottawa River watershed and its tributaries. We also recognize and appreciate the contributions that all First Nations, Métis, and Inuit peoples have made and continue to make in shaping this land we now know as Canada. We acknowledge, respect, and seek to better understand the unique Indigenous history, rights, and title on the lands where we work. Before we kick off the presentation, there is simultaneous interpretation. Click the globe icon on the bottom right if you would like to hear this in French. Today's session is planned for about 45 minutes, 20 to 25 for the presentation and the rest for Q&A. The Q&A icon on your screen, you can type in your questions at any time and we'll take them up at the end. We do record these sessions because we post them on YouTube. We send you the link afterwards when we post them on YouTube, along with any answers to any questions we can't get to. If you have any technical difficulties, please email us at ermstakeholder@cnl.ca and we'll try to get you sorted out. We also send out a quick survey after. It's a 10-question survey. We'd really appreciate it if you take the time to share your thoughts on our webinars, and it really gives us great ideas for other topics moving forward. During today's webinar, you'll be hearing from Josh Carolan. He's the Acting Project Director for Decommissioning on the B250 project, and also from Alfred Otu, Engineering Advisor for Facilities Decommissioning and Environmental Remediation regarding the Dedicated Isotopes Facility, more commonly known or referred to as MAPLES. After the presentation, we'll open the floor to Q&A for both Josh and Alfred. So first off is Josh. So Josh, over to you.
Okay, thanks so much, Mike. Good day, everyone. As Mike mentioned, my name is Josh Carolan. I'm an acting project director here with the Decommissioning Program Execution Group at Chalk River Laboratories. I've been with the 250 decommissioning project since 2020, previously as a project leader and project manager. And I'm really happy to be here today to provide an update on one of the more complex and larger decommissioning projects here at the Chalk River site. And to take a look at all the great work that's being done at 250 as we lead into our planned demolition in a few years' time. So today I'm going to give a bit of a background in history on 250, a quick overview of our decommissioning process and some key activities that play into that process, and some field highlights of the key work completed over the past 2 years here by the team. Next slide. So 250 is a large multi-purpose laboratory facility here at the Chalk River. It was built in 3 separate stages between 1949 and 1953, and it was occupied by the Materials Testing and Chemical Engineering Group predominantly, although some other groups have occupied this building in its 70-plus year operational history. Because it was built in 3 different stages, it's almost 3 different buildings, so we'll often refer to it as the North Tower, Center Tower, and the South Tower. The North Tower was constructed first, and then the South Tower and the Center Tower amalgamated it into one building. Because of this construction, the towers mostly have independent services, which presents some opportunities, but also some challenges to our decommissioning work. Next slide. So here we see the North Tower as an independent freestanding structure. In the North Tower, a set of hot cells and test loops supported the materials testing and chemical engineering work, while the South Tower contains the tritium facility, and the Center Tower was predominantly office space. Various labs exist within this building, and some key equipment in these labs are 66 fume hoods, various test loops, 3 sets of glove boxes, and 2 hot cells. I'll talk to a lot of those systems later on in the presentation. And this really allowed for some active work to be conducted safely within containment throughout the operational history. The building was in operation until it was turned over to decommissioning in 2018. Next slide. So We have the lots of hazards present within this facility. So we obviously have the radiological hazards based on the nature of work conducted throughout the facility. We also have industrial and chemical hazards based on the buildings and materials used at the time of construction. Asbestos containing materials are prevalent throughout the building. We have hazardous energy through our electrical and mechanical systems. And finally, we have the fire hazard as the central and south are predominantly wood construction for the superstructure. Next slide. So a rough outline of our decommissioning process here. So once turned over to decommissioning in 2018, the project began characterization through surveys and sampling to understand the hazards and plan accordingly. Throughout the life cycle of a decommissioning project, characterization is really pivotal, a really pivotal aspect of the process as it drives our decommissioning strategy and waste streams. Our decommissioning approach and schedule was developed in accordance with Reg Doc 211, as well as CSA N 294, decommissioning of facilities containing nuclear substances. And this really provides guidance and best practice for decommissioning and demolition work with respect to the planning and decision making throughout the life cycle of the project. Next slide. So as I mentioned, one of the key aspects is characterization. I just want to talk a little bit about how we perform characterization and why it's so important. As this was a large multidisciplinary laboratory, it hosted various groups, various scopes of work throughout a 70+ year operational history. Detailed characterization of the various systems, whether that be exhaust, drains, fume hoods, piping, surfaces, is required so that the hazards can be understood and planned for during work execution. We have a really great dedicated characterization team here that works with our labs on and off site to understand the sampling analysis results. And that really helps us develop our remediation strategies as well as determines our waste paths. Next slide. Um, hazard abatement and hazard remediation. So upfront, industrial hygiene conducted a baseline assessment and analysis of industrial hazards throughout the building. This was to cover whether there's asbestos, lead, mercury, PCBs, what existed in the facility, and really gave us a baseline of what needed to be remediated prior to demolition. And while asbestos and lead are the largest sources of hazardous substances in our building, things like PCBs, mercury, OCDs exist, and these need to be removed prior to demolition. Next slide. Various complex system structures and components such as fume hoods, glove boxes, test loops, exhaust ventilations, and drains are required to be removed throughout the facility before we get to demolition. We take a systematic approach to removal of these contaminated structures and systems, and this really gives us an opportunity to divert demolition debris from low-level waste stream, and I'm going to detail that in some more slides upcoming. And yes, next slide, please. So one of the most prevalent and extensive systems in 250 are the 66 fume hoods that existed in the various labs. Most of these fume hoods, as we can see on the left, are custom fabricated in situ with either poured lead or concrete bases that were serviced by up to 7 different services, whether it's electrical or mechanical. They also have their independent exhaust and drain services. Since 2022, the project team has removed 62 of the 66 fume hoods in 250, with the removal of the final 4 currently in execution. Through detailed planning and meticulous field execution, all hazardous energies were safely isolated and air gapped, including the ventilation and drains prior to demolition and size reduction. The project and CNL really have been able to continually improve and implement lessons learned from previous work packages, which has not only reduced the execution time for these fume hood removals, but more importantly, has allowed for safer removals. Next slide. In the south tower, with the fume hoods removed, we're able to get to the exhaust system that exhausted these fume hoods. So in the south tower, there were 7 different exhaust systems, and they were used to exhaust the 31 fume hoods, 2 glove boxes, and the laboratories in the south. We did a lot of upfront characterization to understand the contamination present. And once we had that characterization completed, we could get into the removals. So that started with the isolation and air gap for electrically and mechanically, and then it moved into the size reduction and dismantlement of the ventilation system. We can see here on the pictures before and after on the left, we can see the independent ventilation trucks that rise vertically from the fume hoods, where they combine into a common plenum. Next slide. Through our characterization process, several of the ventilation systems in 250 were found to have perchlorate contamination based on the historical use of perchloric acid. So vapors from perchloric acid use would cool as it migrated up the ventilation system, leaving deposits of perchlorate salts, which were identified in two of the ventilation systems in the south tower during characterization. Perchlorate salts are highly reactive, and they pose a risk of fire explosion if disturbed or handled improperly. Um, and this hazard was really compounded with the existing radiological hazard that's present in the ventilation system's past operations. The remediation and removal required a detailed and innovative approach to ensure the both chemical and radiological safety for the workers, in addition to specialized treatment options for the waste. Next slide. So working with an industry partner, a remediation strategy was developed to neutralize this perchlorate hazard. And what the project team did was, with the contractor, developed a life-size mock-up, including custom tooling. And that was really done to validate the work steps and the tooling before it got to the field for the remediation removals. Since perchlorates are water soluble, a custom rinsing system was designed, as well as a water collection and process water filtration system that would be employed here at CNL. The project used approximately 6,000 liters of water to flush out roughly 2,500 feet of ductwork in the two exhaust systems. All that processed water was captured, and the perchlorates were effectively filtered through a filtration skid. This enabled the minimization of waste with perchlorates, um, and it also we were able to process the rest of that water through a waste treatment center here at CNL. Next slide. Another key system we've been able to remove here are the two independent active drain systems. So the north and south had independent active drain systems. Approximately 2,500 feet of active drain lines ran throughout the building. These lines were a mix of lead and stainless steel piping. Both required extensive characterization up front to enable the planning and field execution. And in the south tower, we've isolated from the site active drain system, and in the north, we are currently working on that. Next slide. One of the most unique facilities and systems in 250 are the two hot cells that are located on the fifth and the sixth floor. These are essentially enclosed structures with thick concrete and lead shielding walls so that work could be safely executed by operators behind 60 centimeter sides, 30 centimeter backs, and 15 centimeter lead front walls. The cells were built in two phases, with cell 4 in 1955 and cell 3 in 1960. Cell 3 was used for fuel to solutions, weighing, and analytical work, where cell 4 was used for wet chemical operations, small specimen testing, and long-term crack analysis. By 2023, all loose items had been removed from the project. The manipulators, the interior components removed. The lead glass windows were removed, and we were able to save and repurpose those for some future new builds. What was left was to characterize and remediate as required within hot cells. Our characterization efforts consisted of RP or radiological scans throughout the hot cells, as well as coring in the walls and the floor. And that was so that we could understand the contamination present, as well as the depth of penetration for that contamination. Next slide. So based on our characterization results and understanding of the contamination within the hot cells, we were able to see that the contamination was mostly on the surface. So we developed some work packages to scabble, which is essentially shaving the top layer of contaminated concrete off the walls and floors. Afterwards, our scans showed that this scabbling was successful, and the contamination throughout these hot cells 3 and 4 were greatly reduced. The project also isolated and air gapped the hot cell ventilation system, which had a standalone ventilation system, and installed a new temporary ventilation system that will be in place until demolition. Next slide. Um, this is a recent project completed this fall by our project team, which was a great win for us. So Room 109 was constructed in 1953, and it originally served as a transfer station for air and water testing. In later years, the rooms were repurposed into an air exchange lab for non-radiological catalyst work. But this demolition was really important. It frees up a lot of valuable space for future demolition equipment and plans. And the work that was required to demolition The structure 109 was system isolation. So we had electrical and mechanical systems in there, whether it was water, high pressure air, steam, or sprinklers. Those needed to be isolated so that we could do demolition safely. We had to do characterization. So we had our cores as well as our scans, and that really helped us understand the waste path for this debris. And we also had hazard abatement. So we had a lot of asbestos and mold within this room 109 that need to be abated prior to demolition. Next slide. So here we have some of the waste statistics to date on our project. We can see that the large volume of clean waste that has been removed from the project through characterization, surveys, and verification. This has been able to divert this waste from our active waste streams, which is great. The removal of fume hoods, ventilation systems, active drain systems in the past 2 years can be seen here in these volumes too. And removing these contaminated systems is really a critical step in enabling our demolition plans, and that will ensure a safer and more efficient demolition process when it comes. Next slide. Which brings us to our planned demolition of 250 in 2027, 2028, which our team is working really hard with both our internal engineering team as well as an external engineering firm to develop a demolition strategy and design. Due to the 3 separate towers, a staged demolition is required. 250 is also in a very tight footprint with 2 operational facilities on each side. So the staged demolition is required to reduce site operations to these key facilities. As part of the demolition design, we're working on a dispersion model, and that's being developed in collaboration with CNL's Natural Resources Management team. This model will help ensure that contamination control throughout the demolition process is captured. Finally, as the project finalizes our demolition plans this year, we're really excited to work with stakeholders on this important project that will reduce the legacy liability that currently exists with 250. And with that, I'll pass it back to Mike to pass on to our next speaker, Alfred.
Okay, awesome. Thank you, Josh. Great presentation. And we will move on to part 2 of today's webinar, the dedicated isotope facility decommissioning update. Alfred Otu, he's the engineering advisor for the facility decommissioning and environmental remediation. So Alfred, over to you.
Thank you, Mike. Appreciate the intro. Good morning, everyone. Alfred O2, Engineering Advisor. I was part of the field engineering and execution team in the early 2000s, and later part of the transition team that transitioned the facility from operational to extended shutdown state. So it is quite an honor to be part of a project that I spent quite a few years on. Next slide, please. What is the DIF complex? So the DIF dedicated isotope facility is a complex comprised of the Maple 1 reactor facility, the Maple 2 reactor facility, and the new processing facility. Next slide, please. So the multi-purpose applied physics lattice experimental reactors, MAPLE for short, and Maple 2 are copies of each other. They're 10 megawatt pool type light water moderated and cooled radioisotope production reactors. The Maple 1 reactor was commissioned to a power of 8 megawatts in May of 2003, and from January of 2007 until the decision to discontinue in 2008 was operated at various reactor powers up to 5 megawatts to conduct our various commissioning tests, as well as to determine the causes for the positive power coefficient of reactivity. Overall, if you total the number of operating hours, Maple 1 reactor was operated for about 5 full power days. Maple 2, similar in nature, was also started up, and we were conducting commissioning tests. All the low power tests were completed around January 2004, at which point the reactor was shut down while we focused on Maple 1. The reactor has not been operated since then. Next slide, please. MPF. So the entire DIF complex was designed to function as Maple 1 reactor, Maple 2 reactor, and the new processing facility. This was a self-contained building which was designed to process the irradiated moly targets as well as the iodine components for medical isotopes prior to shipment to MDS Nordion, and the solidification of waste for long-term storage at CRL waste management areas. The MPF completed Phase A non-active commissioning in July of 2000 and began active commissioning in May 2003. However, active commissioning was never completed at the time the DIF project was halted. Next slide, please. So, what is our operational and current status? The development work to commission and start Maple reactors and MPF was stopped in 2008. At the time, Maple 1 and 2 reactors were at various stages of commissioning. The Maple 1 iodine facility, which is in the basement of Maple 1, was also about to start active commissioning, but it was also halted at that time. Both reactors were immediately placed in the alternative guaranteed shutdown state, and MPF was also halted at Phase A commissioning. The project team then transitioned from operational to the extended shutdown state, and that was the state the facility was left in 2003 in preparation 2009, my apologies, in preparation for eventual decommissioning. Next slide, please. So, what are our planned steps before actual decommissioning? All low enriched uranium, fuel bundles, targets, and everything have been removed from the facility. All sources of radioactivity have also been removed from the facility, as well as anything that was remaining that was currently inaccessible is maintained under controls that meet the CNL radiation protection requirements. Measures have been taken for the systems not required to remain operational to be shut down and preserved to prevent accelerated corrosion and aging. Site shared system, electrical, water, HVAC that are not required to be operational in the DIF complex have been isolated. So basically, we're in a nice, safe state to begin decommissioning activities. Next slide, please. Decommissioning phases overview. So in summary, the decommissioning is going to be done in 3 phases. Phase 1, which is where we are currently, preparing for decommissioning. Phase 2, demolition of the above grade structure. And then Phase 3, demolition of the below grade structure as well as surface remediation. Of note, Phase 1 is has been focusing on documentation preparation. We completed a detailed decommissioning plan, which details all our project activities, as well as evaluated our safety assessments, hazards, and decommissioning strategy. And this DDP is ready for submission to the CNSC for acceptance. As part of Phase 1 activities, we've also completed a safety assessment in compliance with Reg Doc 211.2 and CSA standard N294. And the outcome of this evaluation determined that the bounding scenario for all radiological hazards can and will be managed and controlled to an acceptable level and is in compliance with our CNL functional support programs, and all our hazards can be managed safely. Next slide, please. Waste. In terms of our estimated waste, currently for the MPF, we anticipate approximately 68% of our waste will be clean, 0.05 will be hazardous, and 31% will be low level. Next slide, please. The Maple 1 waste, again, this is an initial estimate. Invasive characterization efforts are currently taking place. So the estimated clean waste at this point is 70%. Our hazardous waste is anticipated at 0.12%, and our low levels estimated 29.5%, as well as our intermediate waste is 0.18. Maple 2 waste estimates are anticipated to be the same. Again, these are conservative estimates, and extensive characterization is taking place right now to confirm these waste clarifications. Next slide, please. So where are we? Currently, we are in Phase 1, and demolition is slated to start in 2028 with an anticipated end date of 2036. Further discussions and progress updates will be provided in the future as we progress. Back to you, Mike.
Okay, thank you, Alfred. Great presentation to the both of you, and we will get started on some questions. Okay, what is CNL's plan for the intermediate level waste associated with these decommissioning projects?
Mike, for 250, when we encounter intermediate level waste, we work with our waste management team here at CNL to develop kind of the right packaging as well as the correct waste stream for it.
Okay. Okay, thank you. How do these projects interact with other decommissioning going on in the controlled area at Chalk River Laboratories?
Yeah, so there's quite extensive decommissioning happening all on the controlled area here at Chalk River Laboratories. There's really a calculated and strategic and systematic approach to decommissioning to make sure that all the different projects are communicating with each other to ensure that there's kind of proper coordination between the projects. Also, one really great thing is a lot of the lessons learned or best practices we see that are being communicated amongst the teams. So really we can kind of, learn from each other as we kind of complete our separate scopes of work.
Okay, thank you. Okay, for Josh, what type of challenges are there when isolating and disabling legacy utilities like high-level power to ensure safety prior to activities like intrusive characterization?
Yeah, it's a really great question. So there is a lot of challenges. Probably first and foremost is these are legacy facilities. The configuration isn't always the best. The status of our drawings don't always match kind of the field configuration. Um, so that's definitely a big challenge for us. And how we mitigate that is through, thorough walkdowns in the field with our engineering team and our planning team to ensure that when drawings really aren't up to date in the field, we do update them, kind of redline them, and so that we ensure that the proper isolations are in place before we kind of do any of that intrusive characterization. The other challenge is because these are legacy facilities, sometimes we're dealing with systems and components that are maybe 60, 50 plus years old. They might be not in the best kind of operating condition. So a lot of times we'll be going to do, a mechanical isolation and the valves aren't holding. So we have to kind of go further upstream and find a valve that is working. So really it's just through, really great field coordination and kind of carefully checking the configuration prior to the work being performed.
Okay, thanks, Josh. For Alfred, you're not getting away with no questions, Alfred. Does the detailed decommissioning plan have an option to reuse some of the instrumentation from the facilities?
That's a good question. So, from an internal perspective, we did assess the use of the internal components, systems, and structures, as well as the building to see if there was any long-term use for CNL. Unfortunately, most of the components were fairly old in nature and not really compatible with our existing facilities. So currently, there is no plan to reuse a lot of those components. However, based on this question, we will put in feelers to OPG, Bruce Power, and see if there is some value gained from preserving these components.
Oh, that's great. Thank you, Alfred. Okay. Josh, what's currently the biggest challenge in general with decommissioning a building like 250?
Probably for 250, it would be the footprint of the building. So it's a really large facility on the controlled area. It's in quite a busy quite a busy area. So it's really hard when we're developing our strategy and methodology for the demolition. When we start to think of the heavy equipment that needs to be there to do the demolition safely, the loading of the waste and segregation of the waste. So really, it's coming up with unique and innovative strategies to forward that demolition plan.
Okay, thanks. Josh, again, how did the team plan for such an extensive, known and especially unknown contaminants of potential concern in such a long operating analytical chemistry building like 250?
Yeah, I'd have to give credit to our characterization team as well as our waste team. So it's that upfront characterization, whether it's our non-intrusive kind of scanning and sampling, to our intrusive, getting coupons to understand what kind of contaminants exist within these different systems and structures. Because like the question talks about, there was quite an extensive operating history. Over 70 years, a lot of different things have happened in building 250. So really that characterization lets us get down to the core of what contamination actually exists in these systems, and then we can plan accordingly.
Okay, Josh, popular. For 250, the issue about the fire that happened in the building, how is that being tackled in the entire course of this decommissioning?
Yeah, for sure. So 250 has a history of operational incidents. Probably most notably is a fire that happened on the roof of the hot cell facility in the mid 90s. So the result of this fire and putting out this fire um, did have a result on contamination throughout the building, with really some contamination trickling through the exterior structure of the North Tower. So how we are tackling that is through kind of the scabbling and characterization that I talked about. So we're doing surface characterization of all the surfaces in the North Tower, and then we're remediating through the scabbling as required, and through our characterization, understanding the depth of contamination that exists from this incident.
Okay, awesome. Thanks, Josh. There are a few questions coming in about um, interim storage of waste from 250 and if NSDF is not ready, and ILW storage and stuff. I think we'll keep those away from asking those to our project experts here, and we'll probably bring in someone from waste to respond in writing to some of these questions. With that, another question for Josh. Um, have lessons learned from the British decommissioning program been used? They have similar buildings to CNL. Not sure if you've heard of
Um,
them.
no, that's okay. We definitely have a lot of folks here who work at CNL that were formerly, in the UK through Sellafield or other sites in the UK that have kind of brought in their expertise and lessons learned over here. We've also done some benchmarking with some of the work that's going on in the UK. So yeah, I would say that we are in alignment with the work that's being performed around the world, and especially in the UK, especially on these facilities that are similar in nature.
Okay, thank you. A great bridge from our last webinar. I like this question. The robots from our previous webinar, have they been used in 250 or the Maples?
Yeah, I can speak to 250. So we have had the innovations team in here in 250 to say to do some scans, whether that's LiDAR to help our planning efforts. Most of those times those are just kind of like the remote 3D scans and not the robots. But I can say that in other decommissioning facilities, especially where there is more dose and contamination issues, and we're trying to avoid human entry. We do use those robots in decommissioning.
And not to be left out, DIF is following suit on the 3D scans. the graphic modeling, as well as using the innovations team as well to assist in our decommissioning efforts.
Okay, perfect. Thank you. Okay. Just seeing if there are any more. This is usually where I do my outro sayings, and then a few come in. So just to break the dead air. So we'll do. Thanks for attending these webinars today. Just a reminder that we do send our follow-up survey after this. And we'd really appreciate it if you'd fill it out. It helps us with future topics. We'll send out the links of the recordings once we put them up on YouTube. Feel free to distribute it to anyone who might be interested. And finally, please remember, if you have any questions at any time, you can get in touch with us at ermstakeholder@cnl.ca. One final check if we have more questions. Oh, and our September webinars that we did, one of our topics was the near surface disposal facility that I brought up earlier. If you want to know the latest about it, you can go on YouTube on our CNL page and watch that one. We have it posted on our YouTube page. Just checking one more time. Okay, we'll end it there then. Thank you, Josh and Alfred, for the great presentations. Really appreciate it. Thank you, everyone, for attending. We had a great turnout today. And contact us anytime, and we'll see you next time. Thank you.
Thank you.